The modified Euler's method is a better estimate for a solution to a differential equation than the ordinary Euler method if the average slope over the interval x sub 0 to x sub 1 is used instead of the slope at a point. It reads, find an approximate solution to y prime is equal to x squared over y with the boundary condition that y is equal to 2 when x is equal to 3. Calculate y for x is equal to 3 all the way to x is equal to 10 in steps of 1. This part right here suggests that delta x is equal to 1, and we'll use it as we come up with our solution. The first thing that we want to do is find out the slope is at the point x is equal to 3 and y is equal to 2. So let's go ahead and do that. We have y prime is equal to our first slope, which is this number subbed into 3. Power 2 is 9 over 2 substituted here gives us 2, and our slope is 4.5. So we'll take a note of all the steps that we are doing. We have x, y, 3, and 2. And we found the slope to be 4.5. Our goal is to find the next y coordinate. We know the x coordinate will be 4. We're looking for this, and the way we do it originally is we take 4.5 and we write down y sub 2 is equal to the slope 4.5 times delta x, which is 1. That gives us 4.5. And we add 2 plus 4.5, which gives us 6.5. Although according to the modified Euler's method, this number is not good enough, we want to do a better job than 6.5, and there's a better mousetrap to this. In fact, what we do is we take this 0.4 and 6.5 and find its slope. Let's go ahead and do that. We have y prime is equal to our second slope, and our formula was x to the power of 2 over y. So we have 4 to the power of 2 over 6.5, and this gives us approximately 2.46, so instead of 6.5. What we can do is write down y sub 2, our second ordinate, is equal to our previous ordinate, which was to this number, plus the average of the slopes that we found, this one and the previous one. So 2.46 plus 4.5, and when you take the average, you add them up and divide by 2. We then multiply this by delta x, which is equal to 1. So a new y coordinate instead of 6.5 is 5.48. Now that we've corrected our ordinate, we're going to go ahead and find a new slope using 4 and 5.48 as a point. So our new slope is, our equation was x to the power of 2 over y. X is 4 to the power of 2, 5.48 is our y. Let's find out our new slope is equal to 2.919 or 2.92. And with that, we can once again find out what the coordinate will be. Our next point will be at x is equal to 5, and let's find out its y coordinate using the original Euler's method. We can do that by saying y sub 3 is equal to the slope 2.92 times delta x, which is 1, and then we take this number and add it to the 5.48, will give us our predicted y coordinate. This gives us roughly 8.4, but once again, this is not good enough, and we have to correct this way. We correct it, we use the same method as before. So what we can do is use these points to find the slope, and we can do that easily by taking m is equal to our function, which was x to the power of 2. So 5 to the power of 2 over 8.4, we have 2.97. Now, like I said, this is not good enough, so we will use the exact same formula as before, but instead of y sub 2, we will be using y sub 3 is equal to our previous y. Our previous y was 5.48 plus the average of the two previous slopes, this one 2.97 plus this one 2.92, divided by 2. We're taking the average times 1, and we get a corrected value of 8.425. So far, we have 3 points and 2 corrections. If you do this up until x is equal to 10, you should end up with a table that looks like this. And that is how to use the modified Euler's method with predictor-corrector steps. Thank you.